Welcome back, focused learners. Today, we have an incredibly special explainer lined up for you. We are diving deep into the examiner's playbook to see what it actually takes to crack the Cambridge AS and A-level computer science exam, specifically subject code 9618. We're going to conquer a critical, unavoidable topic, the linked list as an abstract data type. I want you to think of the strategies we cover today like magic spells. In the exam room, your structural frameworks are your spells, and casting the exact right one is what guarantees maximum marks. So let's figure out how we can truly master this together.
Okay, let's look at our roadmap for today's session. We've got 5 key areas to hit. First, the challenge. Second, hunting for method marks. Third, the procedural framework. Fourth, avoiding top examiner traps. And finally, mastering evaluative thinking. Let's get right into it. Section 1, the challenge, decoding the abstract data type.
To start, we have to ask a foundational question, one that comes straight from the senior examiners themselves. Why do students find interpreting complex binary representations so incredibly hard? You know, we see 2 types of students fail here all the time. You have a student, let's call him Alex, who overloads his answers with raw computer science facts but provides zero analysis. Then you have Sam, who just rushes and completely misses the command word requirements. If you've ever stared at a test paper and felt completely lost looking at raw data structures, you are absolutely not alone. It's tough, and it's tough because this topic targets 3 rigorous cognitive domains all at once: knowledge, application, and analysis. It's simply not enough to just memorize what a node or a pointer is. You've got to interpret the data, perform calculations from those binary representations, and draw evidence-based conclusions under intense time pressure. Oh, and before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, what's really fascinating here is this direct quote from the principal examiner report. They noted, candidates referencing cross-topic connections achieve significantly higher marks. The theoretical architecture of a linked list isn't just floating in isolation, guys. It rests on precise definitions and causal relationships with other areas of your syllabus. Linking this topic's architecture to other concepts, like memory management, recursion, or other algorithms, is your first major secret to unlocking those higher grade boundaries. The examiners want to see that you understand the whole ecosystem, not just some fragmented piece of it.
Moving on to Section 2, hunting for method marks. The process is the prize.
Let's define the method mark strategy. In the heat of the exam, it is so common for students to panic if they can't visualize the final, perfect compiled code right away. But listen carefully to me. Your final answer is not the only thing that matters. The examiners award marks for the process. If you can demonstrate step-by-step decomposition, systematic analysis, and solid algorithmic thinking, you are going to pick up crucial method marks along the way. Even if your final code has a slight bug, or your binary calculation is just a tiny bit off, selecting the appropriate data structures and showing a logical, structured approach will consistently secure you marks. The assessment framework prioritizes analytical depth over superficial breadth. You just have to show them how you think.
That brings us to Section 3, the procedural framework, cracking the code.
Whenever you face a complex linked list question, you need a reliable system. You need that magic spell. Here is the 5-step procedural framework directly aligned with examiner expectations. Step 1. Deconstruct the question. What is it really asking you to do? Step 2. Extract the relevant data. Pull out those binary representations or specific node values. Step 3. Select your analytical framework. Are you inserting, deleting, or traversing? Step 4. Execute with clear notation. This means designing the algorithm or writing the code implementation efficiently. And finally, Step 5. Present correctly, using the exact, proper terminology expected at the AS and A-level standard. To help you lock this framework in, here is a super quick memory hack. Just remember the acronym DCEP. Deconstruct, extract, select, execute, present. DCEP. Literally write it at the top of your scratch paper the second the exam begins. When the pressure spikes and your mind goes blank looking at a complex, abstract data type, use DCEP as your mental anchor. It will instantly pull you back into the procedural framework, ensuring you don't skip steps and lose those vital method marks we just talked about. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We have helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump into Section 4, Avoiding Top Examiner Traps, the Pitfalls.
Understanding where others go wrong is just as important as knowing what to do right. Remember our rushing student Sam? Well, the principal examiner reports highlight 3 classic trapdoors that catch students like Sam every single year. Trap number 1, using the wrong formula or algorithm for the context. You might write a gorgeous traversal algorithm, but if the command word asked for a search function, you score absolute 0. Trap number 2, forgetting boundary conditions in edge cases. With linked lists, what happens if the list is completely empty? What happens if you are deleting the very last node? You must check these edge cases. And trap number 3, answers lacking specific context. Generic textbook answers just don't cut it anymore. Your response must be deeply integrated with the specific scenario provided in that exact exam prompt.
Here is a major examiner alert to keep on your radar. A weak response often jumps straight into extended writing, resulting in candidates confusing key terminology halfway through their answer. The strong response, it defines key terminology first. Always define your terms before using them in extended responses. It provides a rock-solid foundation for your argument and proves to the examiner immediately that your knowledge base is legitimate. Don't rush into the weeds without planting your signposts first.
Finally, we reach Section 5, Mastering Evaluative Thinking, the final tier.
Higher-order assessment objectives demand so much more than just writing code that works.